The National Electrical Code, or NEC, outlines requirements for hazardous location installations, and Section 505.18 specifically addresses the need for qualified personnel in the design and supervision of such installations. It states that hazardous classified locations shall be designed and supervised by a qualified person who shall be familiar with the following: a professional engineer, or P, who supervises the design of a hazardous location, or HAZLOC, installation is expected to provide several key elements. Firstly, review and approval of design documents, including plans, specifications, and calculations to ensure compliance with the NEC and other applicable codes and standards. Secondly, supervision of installation by providing field oversight to ensure proper installation and testing of all equipment and systems. Thirdly, certification of compliance, including signing and sealing a document attesting to the compliance of the installation with the NEC and other requirements. Fourthly, training and consultation by providing guidance to personnel involved in the design, installation, and operation of the HAZLOC facility. Fifthly, documentation to maintain records of all design calculations, inspection reports, and certification documents. For a Class 1, Division 2, Group B, or Code D2GB classification, which indicates a specific type of hazardous location, the PE must be familiar with the specific NEC requirements for this classification. This includes, firstly, the types and ratings of equipment and materials allowed in the area. Secondly, the ventilation and grounding requirements. Thirdly, the lighting and electrical wiring methods. And fourthly, the emergency preparedness and response plans. To prepare for an operational readiness review, it's important to ensure that you have documentation from a qualified PE confirming, firstly, review and approval of the design documents. Secondly, supervision of the installation. Thirdly, certification of compliance with the NEC and other applicable codes. And fourthly, training and consultation provided to relevant personnel. Let's delve deeper into each of these responsibilities. Regarding the review and approval of design documents, the PE acts as a critical safeguard, meticulously examining the plans, specifications, and calculations to ensure that they align with the NEC and all other relevant codes and standards. This review encompasses various aspects, from the selection of appropriate equipment and materials to the design of electrical systems that minimize the risk of ignition in the hazardous environment. The PE expertise ensures that the design is not only technically sound, but also adheres to the stringent safety requirements mandated by the NEC. Concerning the supervision of installation, the PE role extends beyond the design phase to encompass the actual implementation of the plans in the field. Through diligent field oversight, the PE ensures that all equipment and systems are installed correctly and tested thoroughly. This involves verifying that wiring methods are appropriate, grounding systems are properly implemented, and all safety devices are functioning as intended. The PE presence on site helps to identify and address any potential issues that may arise during installation, ensuring that the final result meets the required safety standards. With respect to the certification of compliance, the PE assumes a significant responsibility by formally attesting to the compliance of the installation with the NEC and other applicable requirements. This certification typically involves signing and sealing a document that serves as a formal declaration of the installation's adherence to all relevant codes and standards. This document provides assurance to regulatory authorities and other stakeholders that the HAZLOC installation has been designed and installed in accordance with best practices and legal requirements. In terms of training and consultation, the PE also plays a vital role in educating and guiding personnel involved in the design, installation, and operation of the HAZLOC facility. This may involve providing training sessions on specific aspects of hazardous location safety, offering guidance on the selection and use of appropriate equipment, and consulting on any technical challenges that may arise during the project. The PE expertise helps to ensure that all personnel involved are adequately informed and prepared to work safely in the hazardous environment. When it comes to documentation, the PE is responsible for maintaining comprehensive records of all design calculations, inspection reports, and certification documents. These records serve as a valuable resource for future reference, providing a detailed history of the design, installation, and maintenance of the HAZLOC installation. They can also be used to demonstrate compliance with regulatory requirements and to facilitate any necessary audits or inspections. In addition to these general responsibilities, the PE must also be familiar with the specific requirements for the Code D2GB classification. This classification denotes a Class 1, Division 2, Group B hazardous location, which presents unique challenges in terms of electrical safety. The PE must have a thorough understanding of the types and ratings of equipment and materials allowed in the area, ensuring that all components are suitable for use in the presence of flammable gases or vapors. The ventilation and grounding requirements for Code D2GB locations are also critical considerations. The PE must ensure that the ventilation system is designed to effectively remove any potential buildup of flammable gases or vapors, and that the grounding system is properly implemented to minimize the risk of electrical shock or ignition. Furthermore, the PE must be familiar with the specific lighting and electrical wiring methods that are permitted in Code D2GB locations. These methods are designed to minimize the risk of sparks or other ignition sources that could ignite the flammable atmosphere. Finally, the PE must be aware of the emergency preparedness and response plans that are in place for the HAZLOC facility. This includes knowing the location of emergency shut-off switches, fire extinguishers, and other safety equipment, as well as understanding the procedures for responding to fire, explosion, or other emergency. In preparation for your operational readiness review, it is essential to ensure that you have documentation from a qualified PE confirming their involvement in the various stages of the HAZLOC project. This documentation should include evidence of the PE review and approval of the design documents, the supervision of the installation, and the certification of compliance with the NEC and other applicable codes. It should also include records of any training and consultation provided to relevant personnel. By having this documentation readily available, you can demonstrate to the reviewers that you have taken all necessary steps to ensure the safety and compliance of the HAZLOC installation. The PE role is paramount in ensuring the safety and reliability of electrical installations in hazardous locations. Their expertise and oversight are essential for minimizing the risk of fire, explosion, and other hazards that can arise in these environments. By adhering to the NEC requirements and working closely with a qualified PE, you can help to protect personnel property and the environment from the dangers of hazardous locations. It is also important to maintain a comprehensive understanding of the NEC articles related to hazardous locations. This includes Articles 500.4 through 500.7, which covers general requirements for hazardous locations, 505.1 through 505.25, which covers Class I, Zone 0, Zone 1, and Zone 2 locations, and 506.1 through 506.25, which covers Class Roman II, Division 1, and Division 2 locations. By staying up to date on the latest NEC requirements and best practices, you can ensure that your HAZLOC installation remains safe and compliant throughout its lifespan. In addition to the NEC, there may be other applicable codes and standards that must be considered in the design and installation of a HAZLOC facility. These may include standards from organizations such as the International Electrotechnical Commission, or IC, the American Petroleum Institute, or API, and the National Fire Protection Association, or NFPA. The PE should be familiar with all relevant codes and standards and ensure that the HAZLOC installation complies with all applicable requirements. The selection of appropriate equipment and materials is another critical aspect of HAZLOC design. The equipment and materials used in a hazardous location must be specifically designed and certified for use in that environment. This may involve using explosion-proof enclosures, intrinsically safe circuits, or other specialized equipment that is designed to prevent ignition of the flammable atmosphere. The PE should carefully review the equipment and materials being used in the HAZLOC installation to ensure that they are appropriate for the specific hazards present. Regular inspections and maintenance are also essential for maintaining the safety and compliance of a HAZLOC installation. Inspections should be conducted on a regular basis to identify any potential problems or hazards, such as damaged wiring, loose connections, or malfunctioning equipment. Maintenance should be performed as needed to address any identified issues and to ensure that all equipment is functioning properly. The PE can play a role in developing and implementing a comprehensive inspection and maintenance program for the HAZLOC installation. The operational readiness review is an important opportunity to verify that the HAZLOC installation is safe, compliant, and ready for operation. By preparing thoroughly for the review and providing all necessary documentation, you can demonstrate your commitment to safety and ensure that the installation meets all applicable requirements. This preparation should also include reviewing all relevant documentation such as design drawings, specifications, and equipment manuals. It is also helpful to conduct a walkthrough of the HAZLOC facility to identify any potential issues or hazards. By taking these steps, you can ensure that the operational readiness review is a success and that the HAZLOC installation is ready for safe and reliable operation. The role of the professional engineer in HAZLOC design and installation is multifaceted and crucial. Their expertise ensures compliance, safety, and reliability in these challenging environments. They ensure proper equipment selection, grounding, bonding, and wiring methods. PE must be well versed in the latest editions of the NEC and relevant industry standards. In Class 1 hazardous locations, which involve flammable gases or vapors, PE must understand the zone or division system used to classify the risk of explosion. Division 1 locations have a high probability of flammable substances being present, while Division 2 locations have a lower probability. Zones 0, 1, and 2 offer a similar classification system based on the frequency and duration of explosive atmosphere presence. Group classifications, such as Group B in the Cone D2GB designation, define the specific type of flammable substance present, influencing equipment selection. Group B includes gases like hydrogen or manufactured gas containing more than 30% hydrogen by volume. PE must meticulously select equipment certified for the appropriate class, division, or zone and group to prevent ignition. For example, explosion-proof enclosures are designed to contain an internal explosion without igniting the surrounding atmosphere. Intrinsically safe circuits limit electrical energy to levels that cannot cause ignition even in fault conditions. Proper grounding and bonding are essential to minimize static electricity and prevent sparking. Wiring methods must comply with NEC requirements for hazardous locations, such as using rigid metal conduit or cable with appropriate seals to prevent the propagation of explosions. In Class Roman II hazardous locations involving combustible dust, PE must consider the dust's conductivity and explosibility. Equipment must be designed to prevent dust accumulation and overheating. Enclosures for Class Roman II locations are dust-tight to prevent dust from entering and potentially causing an explosion. Temperature ratings of equipment are crucial to prevent the surface from exceeding the ignition temperature of the dust. In Class Roman III hazardous locations, involving ignitable fibers or flyings, PE must ensure that equipment is designed to minimize the accumulation of these materials and prevent overheating. Enclosures for Class Roman III locations are designed to prevent fibers from entering and causing a fire. Regular inspections and maintenance are vital in all hazardous locations. PE should establish a schedule for visual inspections, electrical testing, and equipment maintenance. These inspections should verify the integrity of enclosures, grounding connections, wiring, and other safety features. Any deficiencies should be promptly corrected to maintain a safe operating environment. Furthermore, PE should provide training to personnel working in hazardous locations. This training should cover the hazards associated with the specific location, proper use of equipment, emergency procedures, and relevant regulations. Documenting all aspects of the design, installation, inspection, and maintenance is crucial. This documentation serves as evidence of compliance and provides a valuable resource for future reference. PE should maintain records of design calculations, equipment certifications, inspection reports, maintenance logs, and training records. By diligently addressing these considerations, PE play a vital role in mitigating the risks associated with hazardous locations, protecting personnel, and ensuring the safe operation of facilities. Remember that regulations and standards may change. Stay updated with the latest versions of the NEC and other relevant publications to ensure that your practices align with current requirements.